Hey guys, welcome to the Pre-algebra 8.5 video where we're going to be talking much more about slope-intercept form. Alright, so let's do a little bit of review of slope, and we know slope to be rise over run. So why don't you take a second and I want you to calculate or find the slope of the orange line and the black line and then play the video when you're done. Alright, so we remember that slope is rise over run. So let's talk about the orange one first. Alright, well, I can go from this point to this point, or from this point to this point. In either way, I'm going to get the same answer. So if I went from here to here, okay, how many would I rise? Well, that sounds kind of weird because I'm going to a point that's lower. But rise could mean up or down. And so I'm going to rise 1, 2, -3. I'm rising -3. And then I'm running 1, 2, 3. I'm running +3. Now we need to simplify that down to -1 over 1. Now what if I went from here to here? Well, I would rise +3, but I would run a -3, okay? But that also simplifies down to a -1 over 1, and then we see that it's the same. Okay, now the black one, to go from here to here, well, I would rise 1, 2, and then run 1, 2, 3, 4, 5. So we're going to have a 2 over a 5. Or I could go from here to here, in which case I would rise -2, and then I would run 1, 2, 3, 4, -5, because to the left means negative. Well, what's a negative over a negative? Well, we know that translates into a positive over a positive. So same thing both times. All right, what is intercept? Well, we talk a lot about y-intercepts when it comes to equations that have slope. And with slope-intercept form, the intercept that we refer to is that y-intercept. So what is a y-intercept? Well, a y-intercept is where a line crosses the y-axis. So what would be the y-intercept of the black line? Well, here's our y-axis. Now, where does this black line hit the y-axis? Well, it hits it right there at 3. So the y-intercept for this one would be 3. Okay, and when it comes to slope-intercept form, we know that's y equals mx plus b, and we know b stands for the y-intercept. So I would say the y-intercept is 3, or I could say, maybe better, is b equals 3. The y-intercept equals 3. Why do we use b? I don't really know. We can't use y, though, because y is already used over here, so they use b. All right, what is the y-intercept of the orange line? Well, it hits the y-axis right at there, which is 2.5. So b equals 2.5, and then the blue line hits the y-axis right there at b equals -2. All right, so let's talk a little bit more about slope-intercept form. Again, let's refresh. We have y equals mx plus b. Again, this could be a minus b if we have a negative y-intercept. Okay, m is our slope, b is our y-intercept. And again, just because this is so important, we're reviewing some examples of equations that are in slope-intercept form. We have y equals 2x plus 4, okay? Y equals -2/3 x minus 1. We have y equals -x plus 7, and these other two, okay? What would the slope be on this one? Well, hopefully you would look at that and say the slope is the number that's right in front of the x, so the slope is 2. What's the y-intercept? +4. Down here, what's my slope? Well, 1/4. It's the term, or the number right in front of the x. What's my y-intercept, though? Well, I actually don't have anything, but a line, you know, if it's, unless it's a horizontal line, it's going to cross, or, pardon me, unless it's a vertical line, it's going to cross the y-axis somewhere, so we could say the y-intercept is actually 0. All right, so why don't you take a second and pause the video, just identify the slope and y-intercepts for all these, and then play it when you're done. All right, so the slope of this one is going to be -2, and the y-intercept is going to be +1. All right, the slope here is going to be -3 over 2. The y-intercept is actually nowhere, so it's actually 0. So it crosses the y-axis at 0, which is also the x-axis at 0. It's the point we call the origin. Okay, we cross the y-axis right there. Okay, down here, slope is 1/2. The y-intercept is -2. And over here, what's the slope on this one? Well, there's nothing in front of the x, except we know there's actually an invisible 1. Okay, so 1 is our slope, and our y-intercept is -41. All right, so let's do a little more work on putting equations into slope-intercept form. I'll do this one first, and I'll have you do the rest. Remember, slope-intercept form is y equals mx plus b. And the big thing we realize here is that y is by itself. Y is currently not by himself on one side of the equation because we have this 2x. So do I divide by 2x? Well, no, because if I divided by 2x and divided by 2x, I'd be left with a 1 right here, and I don't want a 1, okay? All right, so instead, let's subtract 2x from this side, but if I do that, I have to subtract from this side also. And that would cancel there or become 0 and leave me with y equals, can I subtract a 4 and a 2x? No, so I'm going to do the x term first, minus 2x, and then plus a 4, and I'm done. That's in slope-intercept form. So why don't you go ahead, pause the video, and do the rest, and then play it when you are done. All right, so here to put it in slope-intercept form, I got to get the y by itself, like always, and he's not by himself because he's being multiplied by a 3. So I'm going to divide by 3 to get rid of that, but it will leave me with the y, because 3 over 3 really is just 1 over 1, which will leave me with just 1y, which is what I want. But if I divide that side by 3, everything else gets divided by 3. Okay, so 2 over 3 is just, well, I'll leave it as 2 over 3, x. Negative 9 divided by 3 is minus a 3, and you'd be done. Go down here. You might be looking at that and say, oh, well, y is by itself, so I actually don't need to do anything, correct? Well, unfortunately not, okay? So what we got to do is realize that negative y really means negative 1y. And y is only by itself if it's got a positive 1 in front of it. Or, so 1y and y are examples of y that is technically by itself. This is not. So I got to divide by a negative 1, but that means I have to divide everything else by negative 1. And I'm left with, those cancel or become 1. Really just leave me with a y equals 4x over negative 1. Well, that's negative 4x. Negative 7 divided by negative 1 is positive 7, and you're done. Okay, this one over here. A couple things going on. Going to have to get rid of this 10x and make him totally go away, and I need to turn this 2 into a 1. So what I'm going to do first is I want to get rid of this first. Get that x on the other side first. So instead of minus 10x, let's add 10x. That will make that 0, okay? But I have to do the same thing over here. So those cancel or become 0, and I'm left with 2y equals, can't take a minus 8 and add 10x to it, so I just write 10x, and then we have a minus 8. Then lastly, divide by 2, divide by 2, divide by 2. Y ends up equaling 5x minus 4. All right, so go ahead and pause the video again and try this one, see if you can figure it out, and then play it when you're done. Okay, so what is the slope and what's the y-intercept? Well, in order to tell that, I've actually got to put this into slope-intercept form. So I'm going to go ahead and add 2x to both sides because I know the x has to be on the right side. And I'm left with, well, those become 0, and I'm left with y equals 2x plus 49. So now can I answer the question? Yeah, what's the slope? Well, it's going to be 2. What's the y-intercept going to be? 49. All right, so now we're going to talk about the slope of parallel and perpendicular lines. So when we have more than one line graphed on some coordinate plane. So let's talk about parallel lines first, okay? So I'm going to put in here a couple of parallel lines and modify them around just a little bit and take this and do one of those, and that's super awesome. I love that. Okay, so these two lines are parallel. I'll give them arrows because they're lines, not line segments. Now they look parallel, but the question is, like, mathematically, why are they parallel? Well, parallel lines have the same slope, okay? So if we look at this top one, right? Well, I know that is going through that point and it's going through that point. So how do you rise and run to go from here to here? Well, I rise up 1, and then I run positive 2. So the slope is 1 over 2. Well, what's the slope of this one down here? Well, I can tell it goes through, that point and that point. So how do you go from here to here? Well, I'm going to rise 1 and run 2 again, 1 over 2. 1/2, they both have the same slope, therefore they are parallel. Now let's talk about perpendicular, though. Okay, so these two lines look perpendicular, okay, which again, perpendicular lines form a right angle when they cross, right, form a right angle, which really they form 4 right angles. But why is this mathematically perpendicular, okay, aside from the angles? Let's look at the slopes, okay? So let's look at this line right here. How would I rise and run to go from here to here? Well, I would rise -1, 2, 3, so go down 3, and then right 1. So it's -3 over 1. Okay, and that's for this one. Now what about this one right here? Well, I know this line crosses through that point and that point. How do I go from one to the other? Well, to go from here to here, I would rise 1 and then run 1, 2, 3. So I'm rising 1 and running positive 3. So we got a positive 1 over positive 3. and a negative 3 over a positive 1. What do we notice about these two things? Well, if you don't see it, they are called negative reciprocals. So the slopes of, I use that for perpendicular lines, okay, are negative reciprocals. Okay, what is negative reciprocal? Well, let's look at it. One of them was 1/3. The other one was negative 3 over 1. So what is the reciprocal of 1/3? Well, the regular reciprocal, not the negative reciprocal, just the regular reciprocal, is you flip the numerator and the denominator, and you get 3 over 1. Okay, so this is making it just the reciprocal to go from there to there. But then we're going to make the reciprocal negative. And basically all that means is if it's positive 1/3, you then make it negative 1/3. And so this was the slope of this one. This was the slope of that one. They are negative reciprocals to each other. So take a second and tell me, what is the negative reciprocal of 2/3? Hopefully you'd say the reciprocal is 3 over 2. And the negative version of 3 over 2 is negative 3 over 2. And that would be those would be negative reciprocals to each other. What would the negative reciprocal of negative 7/8 be? Well, the reciprocal of negative 7/8 is negative 8 over 7. And then that's the reciprocal. What's the negative version of negative 8 over 7? Well, all you really need to do is say, okay, if it's negative, the negative version of a negative number is positive. If this were positive, the negative version of a positive number is negative. So you just, well, negative 8 over 7, I need to make that positive 8 over 7. Those two are negative reciprocals of each other. All right, so take a minute. I want you to work on these two, see if you can get them right. I bet you can. And then play the video when you're done, and then we'll keep on moving. All right, so what will the slope of a line parallel to y equals negative 3, y equals 3x minus 4 be? So what will the slope be of a line that's parallel? Well, we know that parallel lines have what kind of slope? The same slope. Okay, so what will a different line that's parallel to this be? What will its slope be? Slope's going to be 3 because that is 3. Now down here, what will the slope of a line perpendicular to y equals negative 2x minus 5 be? Okay, well we know that line, or equations, or lines that are perpendicular to each other have negative reciprocal slope, REC. Okay, negative reciprocal slope. So what's the slope of, wow, I just butchered that. Okay, what's the slope of this line? Well, it's negative 2, right? Or negative 2 over 1. What's the negative reciprocal of negative 2 over 1? Well, the reciprocal is negative 1 over 2, and the negative version of a negative number is positive. So what's the negative version of negative 1/2? Positive 1/2. Those two are negative reciprocals. And what's the slope of a line perpendicular to this going to be? That would be the slope of a line perpendicular to that one. All right, so the last one. What I want to know is what will be the slope of a line that is perpendicular to negative 2x plus 3y equals negative 12. Work on that. Think about what you got to do to that to determine the slope, and then tell me what the perpendicular slope would be. Okay, so can I tell the slope of a line when it's not in slope-intercept form? Most of the time, no. So we want to put this thing in slope-intercept form. Again, I'm going to have to get y by itself. I'm going to move the 2x to the other side by adding 2x to both sides first and making it over here 0. And I'm left with 3y equals 2x minus a 12. And then the last thing I do is, of course, divide by 3. And you get y equals 2/3 x minus a 4. Now, I want to know what the slope of a line perpendicular to this be. This is currently just the same as that in a different format. Okay, this is standard form, this is slope-intercept form. But I need to know what the slope of a line that's perpendicular to this, what that slope would be. So what is the slope of this line? Well, the slope is 2/3. Okay, but what is the perpendicular slope to 2/3? Well, again, it's the negative reciprocal. So the reciprocal of 2/3 is 3 over 2, but the negative version of 3 over 2 is negative 3 over 2. An equation that has a slope of negative 3 over 2 would be indeed perpendicular to either this or this. These mean, again, the same thing. So if it's 2/3, it's slope. The perpendicular to 2/3 is -3/2. All right, guys, that's all I got for you. Thanks for watching, and I will see you in class.